Welcome. Let's continue our discussion of measures of central tendency and the housing conundrum with the median. The median is the middle value of the data set when it's ordered from least to greatest. Half of the data is above the median and half of the data is below the median. An advantage of the median is it is not affected by outliers. An example of when to use the median would be when someone scores really high or really low. To find the median, we line up the data from least to greatest, and we find the middle point. If there are two middle points, because there's an even number of data values, we will find the average of those 2 points. Let's look at an example. Let's find the median of the following data. The scores on a quiz out of 10 points were as follows: 2, 7, 8, 5, and 9. First, order the data from least to greatest. Then find the data point in the middle. The way you can do this is by marking off the data points from the ends until you get to the middle point. Since there's an odd number of data points, there is an exact middle in this data set, so the median is 7. This tells us that half of the quiz scores were above 7 and half of the quiz scores were below 7. So the median is 7 points. But what if there's an even number of data points? Let's find the median of the following data. The scores on the quiz out of 10 points were as follows: 2, 7, 8, 6, 5, 9. If we find the middle point, we notice that there is an even number of data points. So there's actually 2 data points in the middle. They are 6 and 7. To find the median, we find the average of those points. So we add 6 plus 7 and divide by 2. So the median is 6.5 or 6.5. In other words, half of the quiz scores were above 6.5 and half of the scores were below 6.5 points. Let's go back to our housing conundrum. What if we use the median instead of the mean to look at our home prices? Again, remember how you find the median? You line up all your data points from least to greatest and you find the middle of the data. And if there's 2 points in the middle, you add them together and take the average of the 2. So scenario 1, here's our possible home values: $117,000, $65,000, $200,000, $53,000, $65,000, and $1 million. What is the median of that data set? Well, if we line up those housing prices from least to greatest and we find the one in the middle, notice there's an even number of data points, so I have to find the middle of those 2. So I have to add $65,000 plus $117,000 and divide by 2. So that would be $91,000. The median house price would be $91,000. In scenario 2, our housing prices are a little bit closer together. $237,000, $215,000, $300,000, $233,000, $305,000, and $210,000. What's the median in this neighborhood? Again, we still have 2 data values in the middle, and so we find the average of those 2. So the median house price in this scenario would be $235,000. So which is better, the median or the mean? If you looked at scenario 2 and scenario 1 using the mean versus the median was a good measure in both scenario 1 and scenario 2. So it was a good descriptor of the data set. The median is a good choice when the data is numerical and it doesn't have to be close together. The mean is a good choice when the data is numerical, but the data is close together. There's no outliers. You can see that in scenario 1, the median is most appropriate since there's an outlier of $1 million that's skewing the mean to be too large. Remember, our mean in scenario 1 was $250,000, whereas our median in scenario 1 was only $91,000. In scenario 2, you can say either measure is fine since there's no outliers. Since housing prices are unpredictable, we typically use the median price instead of the mean in case there are outliers. I hope this helped you see the difference between the median and the mean in a contextual situation. Next up, we'll look at the mode.